Welcome back everybody. I am a teacher from Ilm Online Academy, and in today's video the topic is Redox Reactions. This is basically chapter number 10 of the ongoing series for the Chemistry 0620, and in today's video we'll be having a look at the Redox Reactions. So further ado, let's just begin. And the contents which we discuss today are the combustion reactions, oxidation and reduction, and redox reactions. So let's first start with the combustion reactions. This is the simplest definition for the combustion. It's a chemical reaction in which a substance reacts with the oxygen and the reaction is exothermic. We have read about the exothermic and the endothermic reactions in our previous video of chapter number 7, which is about chemical energetics. So you can check the definition of exothermic and endothermic from that video. So combustion reactions are of great importance and they can be very useful or destructive. The combustion of natural gas is an important source of energy for homes and also industry. So we have two types of combustion reactions, the complete combustion and the incomplete combustion. So first we'll talk about complete and incomplete combustion. This is just there is just a minor difference between these two types, complete and the incomplete combustion. Incomplete combustion, what happens? We have a substance that reacts with the oxygen. So excess of oxygen is there in case of complete combustion. Excess oxygen supply is present, and in case of incomplete there is limited supply of oxygen. This is the first one, and the second difference is in case of complete combustion, carbon dioxide gas is released. The products of overall combustion reactions are the gases carbon dioxide or carbon monoxide. In case of complete, carbon dioxide is released, and in case of incomplete, carbon monoxide is released plus water. So when a substance reacts with the oxygen, we have carbon dioxide or carbon monoxide and the water is released. So this is the difference between these two. In case of complete, the complete combustion of any substance produces carbon dioxide plus water vapors in excess of oxygen. So the reaction for the combustion reactions for methane will be like this. We have methane, CH4, that reacts with the oxygen and it produces carbon dioxide plus water vapors. So this is the reaction of the methane, which undergo a combustion readily and give out a large amount of energy, that is known as fuels, and this reaction is exothermic, means heat is given out in this reaction. We have also the example of a combustion of glucose that is present in our body of our cells. When the combustion of glucose happens, then glucose has the formula C6H12O6, and when it reacts with the oxygen, then we have carbon dioxide plus water. Products are always same in case of combustion reactions, but there is just a minor difference in complete combustion and incomplete combustion. In case of complete combustion, carbon dioxide gas is released because of limited supply of oxygen, and in case of incomplete combustion, because of limited supply of oxygen, carbon monoxide is released. That is more poisonous gas, harmful gas for the human health, for the environment, for the animals, and also for the plants. So we will balance out this equation like this. You have to put the 6 before all these three. So this reaction is exothermic, and this is the overall reaction process for the respiration. In our body cells, glucose react with the oxygen, and this happens in case of the process of respiration. So we have this combustion reactions, and the chemical reaction or a combustion reaction in which the biological cells release energy that is stored in the glucose for use by the cells or by the body. The reaction is exothermic and it produces carbon dioxide and water as the chemical products. So now we'll take the example of another example of the combustion reaction, which is When air is passed over a heated copper, the surface becomes coated with the black copper oxide, and there is no flame, nor is the reaction is very exothermic, but still as an oxidation reaction. So that reaction will be when copper, this is separate example. So we have second example, copper when reacts with the oxygen and we heat them, it forms copper oxide, CuO. We'll balance this equation by putting the 2 in the coefficients. So this process can also be reversed and the copper surface regenerated if the hydrogen gas is passed over the heated material. The black coating on the surface turns the pink as the reaction is reversed. So in case of reverse reaction, what will happen? We have copper oxide. When we add the hydrogen will react with the oxygen, and again the black surface will turn into the pink. So we have copper that is released plus water. I think this should be also in the symbol like this. Okay, so copper oxide when reacts with the hydrogen, it forms copper and water. So by taking this example, the copper oxide is losing the oxygen and the copper oxide is undergoing the reduction reaction. It is losing oxygen and being reduced. So you can see here in the first reaction, copper gets the oxygen, and in the second one, oxygen is lost from the copper to form the water. So the overall reaction of this one will be, we have copper oxide turns to copper, so this one is the reduction reaction, and hydrogen that is present here is turning into the water which gets the oxygen. So this is the oxidation reaction. So this is the reduction of the copper oxide with the hydrogen and also the oxidation of the hydrogen to get the water. There are some important things that you should notice, the words in which we are describing these substances. We have oxidation reactions and we have reduction reactions. Now I will tell you about the oxidation and the reduction. And oxidation is the addition of oxygen. Like from this example, you can see that when oxygen is added in any substance, you call it as oxidation, or when oxygen is removed, you call it as reduction. So oxidation is addition of oxygen, and the second definition for oxidation is the loss of electrons. And now we'll talk about the reduction. I will explain you this. Just first start with the definition. So reduction is the removal of oxygen from any substance, and we call it as that substance is reduced, and reduction is the gain of electrons. I will give you the example how the loss and gain of electrons will happen in that equation. So these are the two definitions. Up till now, we'll also move towards the third definition of oxygen and reduction when we move forward. So first, now you should know about the two definitions: addition of oxygen, removal of oxygen, loss of electrons, and gain of electrons. Reduction is a process in which an atom, ion, or molecule gains the electrons, and oxidation is opposite to that of reduction, in which an atom, ion, or a molecule loses the electrons. To remember this, you can also use a mnemonic as a hint for this one, which is oil, OIL, and Rig. So this is the hint for remembering the oxidation and the reduction reactions. Oxidation, this O represents oxidation, and oxidation is loss. So loss of electrons happens in oxidation, and this one R that represents reduction. Reduction is the gain of electrons, and G represents the gain. So oil rig is a mnemonic for remembering oxidation and the reduction reactions. So there is something important that you should know about these substances. we have a substance which we call it as oxidized. Oxidized means a substance gains the oxygen or it loses the electrons during a chemical reaction. You call it as oxidized. Like this one, hydrogen that is present here is turning into the water by the gain of oxygen. So hydrogen is oxidized to form the water. And copper, where the removal of oxygen happens, you call this substance as the reduced. We can call the copper as this reduced. Copper oxide is reduced to form the copper. This copper oxide is reduced and this hydrogen gas is oxidized. So there is a specific word for calling these substances which are oxidized and which are reduced. Hydrogen is oxidized because it's getting the oxygen, and copper oxide is reduced because the removal of oxygen happens and it is converted into the copper. So this oxidized is a substance that gains oxygen. You can also call it as the loss of electrons, and reduced, that substance that loses oxygen. The two processes, oxidation and reduction reactions, take place together during the same chemical reaction. This is true for a whole range of similar reactions, so we call it as redox reactions. Redox. So we have a word which is known as redox reactions. Because the two processes of oxidation and reduction take place together during the same reaction, and this is true for a whole range of similar reactions. And I will also give you the example of this one, in which we have this red is for the reduction and ox represents the oxidation. So that's why we call it as redox reactions. We have the redox reaction. Red means reduction and ox means oxidation. So redox reactions are those in which oxidation and reduction happens. A reaction that involves both the oxidation and reduction, you call it as a redox reaction. Okay, so example of this one is when we have zinc oxide that reacts with the carbon and it forms zinc plus carbon monoxide. You can see here this zinc oxide is converted into the zinc metal. So the removal of oxygen happens here. So when oxygen is removed, the process is known as reduction, and oxygen is added into the carbon. So you call it this process as the oxidation process. So oxidation and reduction take place together during the same reaction. In this example, we have a redox. This is example of a redox reaction in which zinc oxide is reduced. We call it that substance as the reduced or the oxidized, in which the oxidation and reduction happens. And carbon is called as the oxidized. You can say that carbon is oxidized. In this reaction, in this redox reactions, carbon is oxidized and zinc oxide is reduced to the zinc metal. So the two processes occur together. The zinc oxide has been reduced by the carbon. In carrying out this reaction, the carbon has itself been oxidized to carbon monoxide gas. The oxidation, you can notice that the oxidation never takes place without simultaneous reaction. It is better to call these reactions as the oxidation reduction reactions or redox reactions, because during the redox reactions there is both gain and loss of oxygen. Even also in the combustion reactions, that the oxygen can be thought of being reduced as it is no longer present as a free element. Reduction is also very important as it provides a way of extracting the metals also from the metal oxide. We have another example of this one. First, carbon dioxide that is formed in a furnace is reduced to carbon monoxide by the reaction with the carbon, and that reaction will be carbon dioxide reacts with the carbon and turns to carbon monoxide like this. The carbon monoxide formed then reduces the iron oxide to the iron in the reaction, and that is the central process for this one. We have iron oxide that reacts with the carbon monoxide to form iron plus carbon dioxide. So moderately reactive metals such as zinc, lead and copper can be extracted from their ores by this reduction with the carbon. So this is known as the reduction with the help of carbon. Now we'll take the two examples of the oxidation reactions that we might use in our daily lives. The first one is the corrosion and the other one is the rancidity. So we have corrosion. Corrosion, the name given to the process that take place when the metals and alloys are chemically attacked by the oxygen, water or any other substance found in their immediate environment. Corrosion or rusting happens in the presence of oxygen and water or moisture that are present in it. Both of these are responsible for the corrosion or the rusting of the metals. If there is just one present, then rusting will not happen. So if a metal is reactive, its surface may be attacked by the air, water or other substances. That effect is known as corrosion. And when iron or steel slowly corrodes into the damp air means in the air we know that oxygen gas is present, and damp air means water as a moisture is also present there. So both of these are the responsible for corrosion to happen. And when the iron or steel slowly corrodes in the damp air, the product is the brown flaky substance and you call it as the rust. Iron, when it is exposed to air and oxygen, then what happens? We have rust. Rust is the brown flaky substance. That is produced, and the rusting weakens the structure such as the car bodies. We have iron railings, ships, bridges, and the corrosion of iron and its when it happens we have a rusting, and the rust is the brown flaky substance. So this is the also the example of the oxidation reduction reactions in which oxygen is getting into the chemical reaction. So next example related to the everyday life is rancidity or rancid. You may heard about this word about the butter, and rancid is the process or a term that is used to describe the oxidized organic material or food, usually involving a bad smell. When a substance is oxidized and the bad smell is produced, that is known as rancidity. And the simplest example of this one will be butter. Mostly the butter becomes the rancid just because of oxidized with the oxygen when it gets oxidized. Oxidation has a damaging effect on the food. When we are not storing the food in the refrigerator, then the fats and oils in the butter and margarine are oxidized and they become the rancid. Fats and oils get oxidized and they become rancid, and then we have a bad smell from that. Unpleasant or bad smell. Manufacturers sometimes also add the antioxidants to the fatty foods just to prevent the oxidation. So keeping the food in the refrigerator or in an airtight container can slow down this oxidation process. Otherwise it becomes rancid and unpleasant or bad smell will happen. So now moving towards the next, we have oxidizing agents and the reducing agents. After that, we will discuss in detail the redox reactions related to the electrons loss and gain. So first we'll talk about the oxidizing agents. These are the substances that oxidize another and reduces itself. So this is the simplest definition for oxidizing agents, and these are the substances that oxidizes another substance during a redox reactions and itself reduced during the chemical reaction. For example, we have I will take that example in which we have done about the extraction of the iron in the blast furnace, in which carbon dioxide removes the oxygen from iron oxide. So this is the example for the oxidizing agents. This is the previous example. So carbon monoxide here removes the oxygen from the iron oxide. You can see here iron oxide is converted into the iron metal, and carbon monoxide is converted into the carbon dioxide. So carbon monoxide here removes the oxygen from the iron oxide. So carbon monoxide here, you can see, is the reducing agent. Carbon monoxide is the reducing agent, and here iron oxide is because you can see here oxidizing agents are those that oxidizes other and reduces itself. So oxygen from iron oxide is getting into the carbon monoxide. So the oxidizing agent here is iron oxide, because it helps other to get oxidized. These are the agents or the substances that help the others to get the oxidized, and it reduces itself. Oxygen is getting removed from itself these substances. That's why they are known as the oxidizing agents. These are the substances that oxidizes another substance and reduces itself. They reduce itself. Iron oxide is converted into the iron metal. Oxygen is removed. So itself they reduced, and they help to oxidize the other, like carbon monoxide. So the reducing agent here is carbon monoxide, because oxygen is getting into the carbon monoxide. So the substances that reduces others during a chemical reaction and itself oxidize are known as reducing agents. Reduces itself and reduces others and oxidizes itself. They get oxidized as oxygen is added into the carbon monoxide to form carbon dioxide. So this is the example for the oxidizing agents and reducing agents. Oxidizing agents help others to get oxidized, like carbon monoxide here. Carbon monoxide is getting the oxygen is added into the carbon monoxide. So these are the substances that help others to get oxidized, and it reduces itself. And reducing agents are those substances that reduces others and oxidizes itself in this. So in the process of acting as a reducing agent, the substance itself will be oxidized. The reducing agent will gain the oxygen as it removing from the other compound, and the reverse is true for the oxidizing agent, and oxidizing agent will itself be reduced during the chemical reaction. So this is about the oxidizing agents and the reducing agents. The oxidizing agents, or sometimes we also call it as oxidants. Sometimes we call it as the oxidants, and we have some examples. The commonest oxidizing agents are, I have some examples. Oxygen that is present in the air is the commonest oxidizing agent. That oxidized substances like which we have read about: corrosion, rancidity in the butter. And next we have hydrogen peroxide, H2O2. And next we have potassium manganate and potassium dichromate. So these are the commonest oxidizing agents that are present there, and we sometimes also call it as oxidants. So the next content which we discuss today is the redox reaction, and we will take the second definition. This one. The second definition of oxidation and reduction: the loss of electrons and the gain of electrons. Up till now we have discussed related to the gain and removal of the oxygen. So now we'll move towards the second definition of our redox reaction, which is the loss of electrons and the gain of electrons. So let's start. So oxidation is the loss of electrons and reduction is the gain of electrons. Oxidation and reduction have expanded over the wide range of reactions. So related to this one, we will look the example between the reaction, or the example between the copper and the oxygen. So when copper reacts with the oxygen, when it's heated, we have copper oxide. So this one is balanced chemical equation. It is clear that from here which one is oxidized and which one is reduced. So you can see here copper is getting the oxygen right here. Copper is converted into the copper oxide, so copper is oxidized. You can call copper as oxidized. Oxidized substance from here is copper, and we can also apply the ideas here. So the copper atoms but what has been reduced, you can see here in this example, oxygen is getting reduced. How oxygen is getting reduced? In this reaction, oxygen can be thought of being as reduced because it is no longer present in the free element. So oxygen is reduced and copper is oxidized because copper is getting the oxygen. Oxygen is not as a free element, no longer present as a free element, so oxygen is reduced. Now we'll apply the definition related to the loss and gain of electrons to this example. The copper atoms in the metal have become copper ions into the copper oxide. In this copper oxide, you can see here this is the ionic compound. Copper is a metal, oxygen is a non-metal, so when metal and non-metal react together, they form the ionic compound, and in this ionic compound we have copper ions Cu2 positive and oxide ions O minus 2 negative, and the oxygen molecules in the gas have split and becomes oxide ions in this copper oxide. You can see here these are the copper oxides and these are the oxygen ions. The copper atoms were clearly oxidized during the reaction as they have gained the oxygen. So however, in this process the atoms have also lost their electrons and the oxygen atoms have gained the electrons in this process. So we have the broader definition of the oxidation and reduction. Oxidation is the loss of electrons and reduction is the gain of electrons. And you can also remember the hint which I gave you earlier about the oil rig related to the oxidation and the reduction. So here you can see here we have oxidation numbers that are present in any element, and the oxidation number of the elements that are present in the free state have oxidation number 0. The oxidation number of the free elements is always 0. For example, metals, copper, zinc all have the 0. Like this one, 0 is the oxidation state and 0, and here you can see this is the ionic compound, so minus 2 and plus 2. So copper is changed from 0 to plus 2. The oxidation number of copper changed from 0 to plus 2. So now you can see here copper is losing the losing the electrons. Here copper from the copper atom is converted into the copper oxide, and copper is losing the electrons because the positive 2 sign, the positive 2 means that copper is donated 2 electrons. Positive 2 means 2 electrons are donated from the copper and it forms the copper oxide. Oxygen first in the O2 it has 0, and in copper oxide -2, so that means 2 electrons are gained by the oxygen to form the copper oxide. So oxidation is the loss of electrons and reduction is the gain of electrons here. I have another example and related to this new definition that increases the number of reactions, that we call it as redox reactions. And here there is no transfer of oxygen that is included, but this one is the best ionic equation for the loss and gain of electrons. Like we have zinc plus copper sulfate that forms zinc sulfate plus copper. So here in the free form, zinc has the oxidation or 0, oxidation state of 0, and copper sulfate, this is present in aqueous solution and it forms the zinc sulfate plus the copper. So here we have in the aqueous form, in this aqueous form of copper sulfate, what happens? We have copper ions. So in this aqueous state we have copper ions and sulfate ions that are present there. So copper has the +2, that means 2 electrons are donated, and sulfate has the -2 charge, this is -2. Okay, and now moving towards the zinc sulfate, this is also the aqueous solution. So in that aqueous solution we have Zn +2 and sulfate SO4 -2, and this copper is present in the free element form, so it's 0. So you can see here copper and zinc from 0 to zinc sulfate +2, that means electrons are donated. +2 means that the electrons are donated, so zinc here is oxidized. Zinc is oxidized. There is no addition of oxygen and removal of oxygen in this. You can see here, you can check by the loss and the gain of electrons and also by the ionic equation. So zinc is oxidized because zinc has donated 2 electrons or lost its electrons, and copper changes from +2 to 0, that means copper has gained 2 electrons, so copper is reduced. So here the reduction happens in the copper. This is the ionic equation for the reaction between the zinc and the copper sulfate solution. That is also the redox reaction. Zinc has lost 2 electrons and copper has gained 2 electrons. So this is clear, both the loss and gain of electrons by the different elements during this reaction. We also call it as a displacement reaction because one metal displaces the other. Zinc and copper both are metals, and they displaces each other, and that's why we call it as the displacement reaction. Now moving to another example, we have moving towards another example that on the basis of the definition, which one is the good oxidizing agent. So we have a redox reaction in which we have iodine from the potassium iodide solution, and we will see if this is a redox reaction or not. Chlorine that reacts with the iodine that is displaced from the potassium iodide solution, and when they react together they form chloride ions, plus we have iodine in diatomic form. So from this ionic equation we can see that chlorine atoms of the molecule have gained the electrons. Chlorine has gained the electrons because negative charge is present. Negative charge means that the electrons are gained and positive means electrons are donated. So electrons have gained to become the chloride ions as they have been reduced. So this is the reduction. So this one is the reduction because reduction is the gain of electrons. And iodine, from minus it becomes I2. So that means when electrons are donated or electrons are lost from the iodide ion to forms the iodine. So iodide ions have lost the electrons to form the iodine and now they have been oxidized. They have been oxidized. ये previous का. Okay. So you can see from this example of the redox reactions that involves the loss and gain of electrons. So next, moving towards the oxidation and reduction reactions or redox reactions and during electrolysis. We have read about the electrolysis and also the fuel cells in our video of chapter number 6, which is about electrochemistry. So we will take the example of that electrolysis and fuel cells of the redox reaction. So the reactions that take place at the electrodes during the electrolysis also involve the loss and gain of electrons. Negative ions always travel to the anode where they lose the electrons. In contrast, the positive ions always flow to the cathode where they gain the electrons. And oxidation can be defined as the loss of electrons and reduction as the gain of electrons. So we will take the example of the electrolysis of concentrated sodium chloride solution, and in that we have hydrogen that is formed at the cathode and chlorine that is formed at the anode. Suppose this one is the electrolytic tank in which we have anode and we have cathode that is both connected to the battery, and we have an electrolyte solution. This is the electrolysis of concentrated sodium chloride solution. So Na positive and chloride ions are present there and hydrogen ions or hydroxide ions are present there. So because this one is the redox electrolysis and redox reactions happen there, and this is the concentrated solution of sodium chloride, that means more sodium ions and chloride ions are present there. So we have also read about that which gas will move towards the cathode and which substance will move towards the anode. So this is the positive terminal of the battery and this one is the negative terminal of the battery. Cathode is connected to the negative terminal and anode is connected to the positive terminal of the battery. So hydrogen here, hydrogen gas is formed at the cathode at the negative electrode. Hydrogen ion is attracted towards that, and chloride ions are attracted or towards the anode, and chlorine gas is formed at the anode. Chloride ions are moving towards the anode. So during at the cathode at the anode we have different equations, like hydrogen ions are moving towards that, and as cathode contain the electrons because it is connected to the negative terminal of the battery, so electrons are taken up by the hydrogen ions and they form hydrogen. So as this hydrogen atom is not stable, hydrogen in the atomic form is not stable, so two hydrogen ions will move towards the cathode and they took two electrons and they form the hydrogen gas, which one is the stable. So this is, you can see here, there is a gain of electrons. So when there is a gain of electron, we call it as reduction. So reduction happens here at the cathode during the electrolysis of the concentrated sodium chloride. Next we will talk about at the anode, what reaction will happen here. At the anode, chloride ions are attracted towards that. So when chloride ions move towards that, they give the electrons to the anode to become stable and they form the chlorine gas. Chlorine in the single or at atomic form, it's not stable, so two chloride ions are moving towards them and they form the Cl2 chlorine gas, plus electrons are also donated to the anode and those electrons will be moved towards the battery from the positive terminal. So here you can see that there is a loss of electrons from the chloride ions, so oxidation happens at the anode. Reduction happens at the cathode and oxidation happens at the anode. Oxidation of a non-metal ions always take place at the anode, and reduction of a metal or a hydrogen ions always take place at the cathode. So this is remember by extending the oil rig memory aid to an oil rig cat. Previously we have read about oil rig. Oil rig is the oxidation is the loss of electron and reduction is the gain of electron. This one, now we are extending this one, this memory aid, and oil rig cat. That means that reminds you of the electrode where each chains take place, where both the reduction and the oxidation occur at the same time. The two processes must take place together to produce the electrolytic decomposition of an electrolyte. So according to this mnemonic, you can see that at the anode, what happens? Loss of electrons happen at the anode. An donates anode, and at the anode oxidation happens, or oxidation is the loss of electrons, and cat means cat donates the cathode. So at the cathode, reduction happens. Reduction is the gain of electrons. So you can remember this one by this mnemonic or memory aid, an oil rig cat. That means at the anode oxidation happens and at the cathode reduction happens. So this is the example of the electrolysis, and we have also heard about the hydrogen fuel cells in our chapter number 6 video. You can also check the detailed video from that, and the hydrogen oxygen fuel cell will be here. Like, we have the products. I will just tell you about the equation, that what happens during that. You can check the detail in from chapter number 6. So when hydrogen and oxygen gases react together, they form water, like this. This is the redox reaction that takes place in hydrogen oxygen fuel cells, and this fuel cell generates the energy by controlling highly exothermic reactions of the hydrogen to produce the water. From this you can see that which one is oxidizing and which one is reducing. Oxygen is no longer present in the oxidation as a free element, so, and hydrogen is getting the oxygen, so hydrogen is oxidized and oxygen is reduced because it's no longer present as a free element. So this is the redox reactions related to the loss and gain of electrons. Next we'll talk about the last content, which is about oxidation numbers and the color test for the oxidizing and the reducing agents. So this is the simplest definition for the oxidation number. This is the number that is given to show whether an element has been oxidized or reduced, and the oxidation number of the simple ion is simply the charge that is present on it. So we have noticed that there are names of the several compounds that are written with the Roman numerals in them, and often after the name of mostly the transition metals. So examples of these compounds are, we have like copper. This is the Roman numeral that is present on it, and that represents the specific oxidation state, because the transition elements that are present in our periodic table, in the center of our periodic table, they are very hard, strong and dense material, and they have variable oxidation states. So just because of that, so which ion that is using in that substance, you have to write that in their name also. Like copper has the oxidation number of +2 and also the +1. So the copper 2, that means this Roman numeral indicates that Cu2 positive ions are present in the compound of this copper sulfate. We have another example like iron oxide, iron 3 oxide. We have cobalt 2 chloride. The reason for these numbers is just because of their variable valency. Variable valency or variable oxidation number is the main reason behind it. Just because of the variable valency, you write the numbers like this. Iron in the iron oxide, like we have iron, this iron oxide In this example of iron oxide, iron is present as Fe 3 positive ion, and copper in this copper sulfate that is present as Cu2 positive ion. So these metals can form other ions in different compounds. Ions can be Fe2 positive of iron because iron also has the variable valency, and copper has also the Cu positive 1 ion. So this number is known as the oxidation number or the oxidation state of any element. We have another examples like we have copper. Copper, in case of copper, has the variable valency or oxidation number of +1 and +2. +1 oxidation state is present in CuO2, that is the example, and +2 is present in CuO, just to balance out, +2 and -2. In case of this one, we have +1. Yes, we have +1 that is present on it, and on this compound. And in case of iron, we have variable valency of +2 and +3. Oxygen -2, or यहाँ पे because 2 copper ions are present there, so +1 will be related to that. In case of +2, we have FeCl2, that is the example, and for +3 we have FeCl3. So these are the transition metals and their oxidation number of the metals and examples of the compounds which they are present in. Next we have another example like manganese. Manganese has the oxidation state +2, +4 and +7. In case of manganese oxide, just MnO, the oxidation state is +2. In case of manganese 4 oxide, MnO2, the oxidation state is +4. And in case of +7, we have the compound Mn2O7. That is these are the compounds that are present in the oxidation state of variable oxidation state of the transition metals. So we have some rules related to the oxidation state of the elements that are present there. I'm telling you now the rules one by one, the rules through which you can identify the oxidation state. So the rules to find the oxidation number. The first one, the oxidation number of the uncombined element or the element that are present in their free state, you can call it as uncombined, or means the one that are present in the free state is 0. The oxidation number is 0. For example, in H2, the oxidation number of hydrogen is 0. In this H2, the oxidation state of hydrogen is 0. And in Cl2, another example is Cl2, this one the oxidation state is also 0, which is of chlorine. Now I will move toward the previous example which we have done here. You can see that as hydrogen is getting oxidized with the oxygen, so in this reactants the oxidation state of hydrogen is 0 and that of oxygen is also 0 because they are present as uncombined or in free state. Another one is here. You can see Cl2 is present as a free state, so the oxidation number is 0. And iodide ions, they are present as iodide. Negative charge is already present, so this is not 0 because negative charge is present on it. But in case of iodine that is formed in the product, no charge is present. This is present in uncombined and free state, so the oxidation number is 0. So this is the first rule for this one. Second, oxidation number of an element in the monatomic ion is the charge on it. monatomic ion, if there is any monatomic ion, so the oxidation number is the charge present on it. Like for example, you have zinc, which is present as a +2, and in the previous example we have read about the iodines like this, so the charge is -1. On the zinc we have +2. In case of oxidines, O2 negative, so the oxidation number is the charge, that is -2 on it. So the third rule is, we have the oxidation number of hydrogen, that is usually 1. Oxidation number of hydrogen is usually 1. I'm not talking about hydrogen that is present in H2 state. I'm talking about in some compounds. So the oxidation number of hydrogen is 1. Like for example, we have HCl. So I'm not talking about the hydrogen gas, I'm talking about the compound. The oxidation number of hydrogen here is +1, and that of chloride ion is -1. Hydrogen has a +1 and chloride ion has a -1. Oxidation number of oxygen is usually -2. Oxidation number of oxygen is -2. So these are the rules you should know before assigning the oxidation number of to any element. Sum of oxidation, third one is sum of oxidation number in a compound in 0. So in a compound, the sum of oxidation number is 0. Sum is 0. Like we have H2O. This is the example. In this, hydrogen, as I already told you about, hydrogen has a +1 charge that is present on it, and oxygen has the -2 charge that is present. We have 2 hydrogen atoms. Oxygen has a -2 charge, and hydrogen here, as 2 hydrogen atoms are there, 1 hydrogen atom has +1 charge, and 2 means +2 by multiplying it. So +2 and -2, they cancel out each other, and the sum of these oxidation numbers on any compound, on a neutral compound, is always 0. So the last one is the last rule for working out the oxidation number of an element. The sum of the oxidation number in a compound ion is the charge that is present on it. So if there is a compound ion, if that has already a charge that is present on it, so in that compound ion, the oxidation number is the charge on it, charge present on it. For example, we have manganate ion. The example is manganate ion, MnO4 negative. This is a manganate ion, and in this, the oxidation number of manganese is +7, and the oxidation number of oxygen is -2 plus, here you also have to write the plus, sorry. So -2, and as 4 oxygen atoms are there, and that is equal to the charge that is present on it. Negative charge is present, so it equal to -1. So +7 plus 4 into 2 will be -8. By subtracting these, we have -1, that is equal to the -1. So these are the rules for working out the oxidation numbers for any reaction. Now I will give you an example related to these rules. First, for example, we have zinc. I think we have done with the zinc. Now I will give you another example. For example, we have chlorine gas that reacts with potassium iodide, and it forms potassium chloride, plus we have iodide ions. So first we'll balance this by writing the two before potassium iodide and before potassium chloride. And in this example, we can see here the oxidation number of iodine and chlorine, because chlorine and iodine are present in uncombined state, so the oxidation number is 0 and 0. Generally, the oxidation state of chlorine is -1, and so potassium has +1, just to cancel out each other. Potassium here also +1 and iodine has -1, so they cancel out each other. So in just one molecule of potassium iodide we have +1 and -1 charge that is present on it. So according to this, by the changing in the oxidation number, we have the oxidation and a reduction reaction based upon the change in the oxidation state. And this is also the third definition of oxidation and reduction reaction. Chlorine has the oxidation state of 0 and it changes to oxidation state of -1, you can see here. And iodine, that is present in the potassium iode, has the oxidation state of -1 and that changes to the 0. On the number line we have 0, we have +1, +2 and +3 like this, and -1 that is present on the left side of the 0, -2 and -3. So this is the number line. You can see here, if we move towards the right then the oxidation number increases, and if we move towards the left then the oxidation number decreases. So from 0 to -1, that means there is an from 0 to -1 there is a decrease in the oxidation state, so this one is the reduction. This is the decrease, so this one is the reduction. And from -1 to the 0, because it moves towards the right to the number line, so there is an increase in oxidation state, and increase in oxidation state means that is the oxidation. So here the halogen iodine, oxidation number of the iodine changes from -1 to 0. It has increased. Iodines are oxidized to iodine. The oxidation number of chlorine changes from 0 to -1. It has decreased, and chlorine is reduced to the chloride ions. So we have another example, or we have another definition or third definition related to the oxidation and the reduction. According to this one, oxidation is an increase in oxidation number and reduction is the decrease in oxidation number. So oxidation is the increase in oxidation number. If there is an increase in oxidation number in any chemical reaction, we can say that this one is the oxidation, and reduction is the decrease in oxidation number. So up till now we have read the three definitions of the oxidation and the reduction. First, addition of oxygen is the oxidation, loss of oxygen or removal of oxygen is the reduction, loss of electrons is the oxidation, and gain of electrons is the reduction. Third, oxidation is the increase in oxidation number and reduction is the decrease in oxidation number of an atom or an ion during the chemical reaction. These are the three definitions of the oxidation and the reduction reactions which we have done up till now. So the last one related to this one, which is the color test for the oxidizing and the reducing agents. Next, we will identify the redox reaction by the color change. So according to this one, we will identify by using the color change. We have acidified potassium manganate, and that acidified potassium manganate has, like for example, acidified potassium manganate KMnO4, and this is the oxidizing agent. That means it oxidizes other and reduces itself. It helps to oxidize this other. So this acidified potassium manganate KMnO4 as oxidizing agent is used to test for the presence of a reducing agent. We can use this to test the reducing agent, and this one is used when acidified potassium manganate is added to the reducing agent. Then the color changes from purple to colorless. When the color change happens from the purple to the colorless, and when acidified potassium manganate is added to any reducing agent, the color changes from the purple to the colorless. So you can easily say this by the change of the color from the purple to the colorless. So if we add the potassium iodide, that is Ki, and potassium iodide that acts as the reducing agent means it reduces others and oxidizes itself. So this reducing agent is used to test for the oxidizing agent. And next, when potassium iodide is added to an oxidizing agent, its color changes from colorless to the red-brown color. So these are identifying the redox reactions by the color changes. We have the reactions that involves the acidified potassium manganate, and they are helpful for as they are they are helpful for detecting or reducing agents. You can see here potassium manganate, and the manganese has a very high oxidation state. The solution containing the manganate ion has a purple color. When it is reduced, the manganate ion loses its purple color and the solution appears colorless because of the formation of the Mn+2 ions. So in this test, the oxidation number of manganese is reduced from +7 to the +2. So reactions that involve the potassium iodide, they can be used as a test for any oxidizing agent. Potassium iodide is a reducing agent, but it is used to test for the oxidizing agents, because when we add potassium iodide to the oxidizing agent, the color change will happen from the colorless to the red brown. So this is how you can check that yellow brown or red brown color happens, or the color change happens in this. So color test involving the potassium iodide or acidified potassium manganate solutions can be used to identify oxidizing and the reducing agents, and also the redox reactions. And this is all about today. If you hope you understand all this. If you have any question or any query, you can ask in the comment box. We will meet in the next video.